Hey guys, welcome back. We have been working on different digital sensors, and today I'm going to start working on a new digital sensor that's TSL2571. Now, to explain more about this sensor, let's have a look over the website that is controleverything.com, and here search out for the sensor that is TSL2571, and let's see what we got. So we got that TSL2571 is a light to digital converter programmable analog gain. It's a light sensor in short, and as you can see, these are some of its features which you can have a look over. Now you can also have the purchasing power from here. You can add to cart here. Today I will be interfacing the light sensor TSL2571 with a Raspberry Pi and a Java code. And for Java code, let's have a look over the resource tab, and here comes the Java code sample. Now you can have the code from this very site. You can download as a zip file from this very link. Also, you can have the privilege to download the code from GitHub repository, and it's called Control Everything Community. Now, what we require is to have some hardware along with the sensor so that we can have a setup, connection setup regarding the interfacing. Let's have it. This is our sensor, that is light sensor TSL2571. Now, this is a Raspberry Pi, and these are the GPIO pins of the Raspberry Pi. Now, the first connection is to be among the sensor and the Raspberry Pi, and to make a connection among that we need an I2C shield, which you are able to see on my screen, and it's available on the website controleverything.com. Also, to make further connections with other I2C devices and make that connection a lot easier, we need this I2C shield. Now, gently place over the I2C shield over the GPIO pins of the Raspberry Pi and make a connection. Next connection should be among the sensor and the I2C shield, and we need a connecting cable just like this. Now put up a connection among the sensor and the cable, and while making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly for the I2C shield also. Now to power up the Raspberry Pi, we need a micro USB cable just like this, and gently insert it over the power jack. Finally, the last part is to make an internet connection. We have two ways. First of all is we need an Ethernet cable just like this, and gently insert it over the Ethernet jack. Next, if we don't have the cable, we can also use a wireless nano USB adapter to connect to the internet, and we are done with that. Finally, as all the connections are being set up, next we need a code so that we can interface along with the Raspberry Pi and the sensor. Now to interface the sensor with the Java code and Raspberry Pi, we need to find out the code, and the first step is to log into the website github.com, and here search for the repository that is Control Everything Community, which you are able to see on my screen. Now here type in the sensor name, that is TSL2571, which you are able to see on my screen, and here comes the Java code. Let's have a look over the instructions we need to follow. It says that we have to download and install Pi4j library on the Raspberry Pi, and this is the link which will help us to install the library easily. As you can see, all the relevant information, dependencies, installation commands are there. You can have to follow it. Now get it done, and compilation command and running command is here for the Java code. Now get back to the code. We have to explain it step by step, and it's a .java file. Now we have to import some of the libraries as you can see on my screen, and we have to create a public class named TSL2571. Now the address of the sensor has to be get, and bus.getDevice is 0x39. Now comes the writing part, where we have been selecting enable register having address 0x00 or with command register 0x80, and the command we have sent here is set power on ALS enabled and 0x0p. Then we have to select ALS register time register, address is 0x01 or with command register 0x80, and we are sending A time 2.72 ms, max count equal to 1023, and it's 0xFF. Then we are sending and selecting wait time register having address 0x03, command register or 0x80, sending command for W time equal to 2.72 ms, and it's 0xFF. Last, we are selecting control register having address 0x0f or with command register 0x80, and the command for the gain is 1x, and it's 0x20. Finally, we are done with the writing section. Now we want to get the data back from the sensor. It's reading, and we are reading 4 bytes of luminous data, and it's channel 0, channel 1 data, as you can see. Then we have the conversion of the data takes place that we have just pulled out from the registers, and we are using a lot of formulas, as you can see, and dependencies and if conditions, which are being described clearly in the data sheet. Now what do we need is to output the data onto the screen at last, and it's, as you can see, ambient light luminance, and the unit is lux, and we have formatted it to two places for floating point value. Now as we are done with the code, what do we require is to show the working class of this code. Let's have it. Now comes the interesting part, that is to show the working of this Java code. So for that, copy this entire Java code and open the terminal. Here create a new file, TSL2571.java extension, as you can see on my screen. Paste the code and save it, and this is the command to run it, as you can see on my screen. First of all, we have to compile it, and this is the command, and the code is being compiled and it's done. Now this is the command to run the Java code, as you can see on my screen. Now it's almost constant, as you can see on my screen, the values for the ambient light luminance. Now when I place some object over it, you can see the decrease in the ambient light luminance, and it's decreasing. Now instead of that, when I place some light source object near the sensor, you can see the increase in ambient light luminance. When I take near it, it will again increase, and it keeps on increasing as I place or take near the sensor and the light source. This is how it works. Now what do we require is to show the benefits and the applications regarding the sensor. Let's have it. The TSL2571 family of devices provide ambient light sensing (ALS) that approximates human eye response to light intensity under a variety of lighting conditions and throughout a variety of attenuation materials. While useful for general purpose lighting sensing, the device is particularly useful for display management and with the purpose of extending battery life and providing optimum viewing in diverse lighting conditions. Now these features make it very useful for applications like display management, backlight control, cell phones, PDA, GPS, notebooks and monitors, LCD, LED TVs, and a lot more. Now you can have the opportunity to purchase the sensor from the website, that's controleverything.com, and you can have the code from resource tab. Now also after that you can download the code from there. Well, you can also have the code from GitHub repository, that's Control Everything Community. Now in the end, I would just like to make it clear that in case you guys are in kind of feeling that you are left without fully understanding, you can have your queries on controleverything.com, and also you can post your comments on the community page of this website. For articles and blogs which are relevant to this video, you can contact us on instructables.com, and to subscribe more video tutorials which are relevant to these videos and tutorials, you can go to YouTube channel. In the end, I hope you enjoyed this video. You have a good time. Thanks for watching.